Math is a wonderful thing. Math is a really cool thing. So get off your ass, let's do some math. Math, 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 math. 3 minus 4 is...
-1.
That's right. And 6 times a billion is...
6 billion?
Nailed it. And 54 is a 45 more than... What is the answer, Marta?
9.
No, it's 8.
No, it's 9.
Yes, I was testing you. It's 9. And that's a magic number.
Hello, Algebra 1 students. So welcome back to our Chapter 1 here in Big Ideas. We're looking at 1.5. This is the last section in Chapter 1 where we're dealing with equations. Here in this one, we're rewriting equations and formulas. So we're going to still use all those same techniques of solving equations here in this section as well. So this is what we'll be learning here. And let's go ahead and look at our cartoon of the day before we jump into our lesson. So here's an in the bleachers cartoon on the ski slopes. Big sign right there in the middle of the slope says, "Danger, watch out for warning signs," placed right in the middle of the ski slope. As the guy collides apparently right into that sign. All right, so let's move into our vocabulary, starting with just what is a literal equation. So when we're talking about literal equation, we're just talking about an equation that has more than 2 or more variables. That's what we see. So there's more than one variable. It's going to have 2 or more variables. So we want to write down here on your vocabulary, on page 24, right there, an equation. A literal equation is an equation that has 2 or more variables. And so we're going to solve those kind of equations that have 2 or more variables. Now obviously we can only solve for one variable at a time, and it's going to tell us which variable to solve for. So that's one thing you want to be looking for, is what variable are they indicating for me to solve for. Sometimes they highlight that variable in a different color. Sometimes they put that off to the side and say for, F-O-R, this letter. So you want to make sure you understand which letter to solve for so you don't get confused. All right, let's move on to what we're doing here. All right, so you can see on these questions, we're not going to do these, but just so you can see what we're talking about, here's a literal equation. This is an example of one. 3y plus 4x equals 9. And notice that they did it here in 2 different ways. They highlighted the y in a different color. So that highlighted y right there tells me we want to solve for y, not the x. But they also said this over here, 4y. So even if they didn't highlight the y's, just by showing this over here, 4y, we know we're going to solve for y and not the x. Here's another one that's got another literal equation. It's got actually x and z in this one, actually 3 letters, y, x, and z. So 3 letters, and it highlights the x, so we definitely know we're going to solve this for x, or it also says over here 4x, so we're going to solve for x. Right now it's solved for y, and we want to get it to where it says x equals. And so that's what we're going to be looking at on our extra practice. So let's go over to that page. Okay, so in here, it's extra practice page 25. It says in exercise 1 through 6, solve the literal equation for y. So right there, it tells us what variable to solve for. We're solving for y. So in equation number 1, we have an x and a y. So we're solving for the y that's right there, which means I need to have that by itself. I need to get rid of my negative 2x. So I'm going to move that to the other side where 15 is. So that means I have to add, do the opposite operation, add 2x to both sides. That will cancel out the 2x's here on the left. So that'll leave me just with y on the right. And on the left, just with y on this left side now, because these are canceled. On the right side, I'm going to have the 15 plus the 2x. Now I could put 15 plus 2x, be okay, or I could put 2x plus 15. It's a positive 15. That's the way I'd like to do it. I like to keep the variable term in front of our number, because that's going to be definitely something we will see as we get into linear equations in a certain form called slope-intercept form when we get there. So I like to keep it in that form. All right, so go ahead and pause the video. Try the same thing on number 2. There's your y right there. We're solving for that. So it's again, same thing on this one. You just got to move the 4x over to the other side. So pause the video and then play it again to check your answer. Okay, so hopefully you did pause your video, and so all you're going to do is subtract 4x from both sides, so y will be over here on the left. On the right side is going to be a 2 minus a 4x. You could say that, or you could say negative 4x plus 2, because it is positive 2. That's what I said here. Y equals negative 4x plus 2. I subtracted the 4x, so now it's a negative 4x, but 2 is positive, so it's positive 2 plus 2. Okay, so now on this next one, number 3, y is over here with that 5. We need to get this by itself. So the first thing we need to do is get this term by itself, 5y. And so to do that, we need to move the 8 to the other side. So we got to subtract 8 first from both sides. That way it cancels it here. I'm going to combine negative 2 and negative 8 to make a negative 10. So on the left side, I have a 5x minus 10. And now on the right side, I just have my 5y term. So now that's by itself. But now to get y by itself, I have to undo the 5. Since it's multiplying, we do the opposite operation. So I'm going to divide everything here by 5. So I'm dividing here by 5 to undo. But notice I'm going to divide, since there's 2 terms over here, I'm going to divide each term individually also by 5. Now I could have put one big fraction bar and put 5 underneath, but I like to do it individually because we need to do that anyways. So that way over here we have 5s are going to cross cancel. That is going to leave me with an x. 10 and 5 will simplify to a negative 2, and now our y will be by itself. So I'm going to, since y right now is on the right side, and I like keeping the y first, so I want to put the y up first here actually. So I'm going to kind of switch this around here, put the y first, and then it will equal, the 5's cancel, equals the x, and then negative 10 divided by 5 is the negative 2. So it just equals this now. Y is equal to x minus 2, and there we have it in this form. And again, each one of these forms so far has just been the form that we're going to eventually see in a future chapter when we're dealing with graphing linear equations. Here's another one, number 4. Go ahead and do this one. Pause the video and do number 4. You're going to solve, again, there's y, solve for y. Just move the x to the other side. Okay, so hopefully you paused the video and now you're just playing it to check your answer. If I just move x, that means I'm going to subtract x from both sides. That just gives me now y by itself. The x will no longer be here. It's going to be over on the other side with 11, but it's going to be negative x. Now I could have said 11 minus x. That would have been okay. These two, you can switch the order. You just make sure the sign's correct. It's got to be a positive 11. It has to be a negative x. Again, I like putting x first because that's going to be the form we're going to see. Number 5, we want to solve this one for y. So I need to first move the 3x term to the other side. So I need to subtract, since it's positive 3x, I'm going to subtract 3x from both sides. That way it cancels, 3x is here, but now y is negative. And that still leaves us with a problem there. We can't leave the y negative in the answer. So we're going to see a negative y, and it's equal to this over here. I like, again, put the 3x first, negative 3x, then minus 4. It wouldn't be wrong to put the negative 4 first, but again, I like putting my variable term first and then the number. So I have a negative y is equal to negative 3x minus 4. But now I need to deal with this negative. I need to change it from a negative y to positive y. To do that, you just need to multiply it by a negative 1. So when I multiply both sides, we need to multiply both sides here by negative 1. So I'm going to put parentheses around both sides. Negative 1's on the outside, so negative times negative will leave me with positive y here. Now negative 1 times both of these is just going to change the sign, so it's a positive 3x and a positive 4. So it's y equals positive 3x plus 4. That's my answer. And now for our number 6 problem, go ahead and try this one. Here, pause the video, see if you can do this one. Y is over here with 4 at the end, so it's very similar kind of to number 3, as we did 3. So go ahead and try this one, and then play the video again once you're finished to check your answer. Okay, so hopefully you've completed that. Hopefully you got an answer for y. Y equals something here in terms of x, because x is the only other letter right now. And so the first thing we need to do, again, is move the 7 to the other side. So we got to subtract 7 from both sides. Cancels the 7's here. So now the only thing I have is a negative 4y. But over here I have to take 1 away from negative 7. That's going to leave me with a 3x minus 6 on the left side equal to the negative 4y. And now I need to undo the negative 4 by dividing by negative 4. So don't change the opposite sign. Remember, it's exactly what it is here because you need these to cancel. So you have to divide by -4. If it's multiplying by -4, you have to divide by -4. That way the negative times negative over negative will be a positive and leave me with that positive y, so I don't have this situation where my y would be negative. So 4's cancel here. On this side, we see some fractions. We're going to see a negative fraction here, and it's a -3/4 x. This one, it will be positive, negative over negative, but I can reduce this by 2. So 6 will become 3, 4 will becomes 2, and here's just the y over here. Again, I like to put the y first, so I'm going to put y first, and then these two fractions here second. And so my answer is going to say y is equal to the first fraction, -3/4 x, so I got those numbers exactly the way they are, plus, because it's negative over negative, and it's 6/4 is simplified to 3 over 2. Just reduce each top and bottom by 2, because they're both even numbers, so now it's 3 over 2. And there's my answer. Again, I like keeping it in this fashion because this is the way we're going to see it when we get to graphing lines in a future lesson. All right, so on 7 through 12, just continue on page 25. So notice this one says 4x. We're solving the little equation 4x. So that's why I highlighted that for us this time. It's not 4y, it's 4x. So in our number 7 problem, we see x is actually in 2 places. So x is on the 10 and it's on the 4. So what we need to do, if it's in 2 places, that means we need to somehow get the x together in only one term. Right now it's in 2 separate terms, and we need to put those terms together somehow, or somehow get the x just only in one place. And so this would be easy to do. It's just you can combine like terms since they're both like terms here. So we're going to start off by just saying y is equal to, and then just 10 minus 4 is going to give us 6x. So we can just combine those like terms to give us that. And now to solve for x, we need to undo 6. So divide by 6 as we're multiplying by 6. So the opposite operation would be to divide by 6. So our 6's cancel. Remember, it's exactly the same number over itself. That's why they can cross cancel. And so now x is equal to, I like to put that first. So let's put the x equals first, then it equals this fraction here of y over 6. And that's our answer. So that was fairly simple to do on that one. Number 8, again, we're looking for x. So x is not only just in one place here, it's also in 2. So look for, maybe it might be in 2 places sometimes, and you got to notice that. So I'm going to have to somehow put these together, but I can't do it the same way here because these are not like terms. This one ends with x, this one ends with x and z. So I can't just add 3 and 9 because they're not like terms. These are like apples and oranges. They're not the same. You can't put them together. So we have to figure out a different way to be able to get the x only in one place. So what we can do instead is pull out x. Instead of pushing these two together like we did here, because they're exactly the same terms, these are not the same terms, so what we can do is we can pull out x from each term. So we start off with the q equals, and then I'm going to pull out x, and I'm going to put x outside of a parenthesis, and I'm just going to write what's left from each term. So when I pulled x out of this one, the only thing left there is 3. And then I pulled x out of this one, the only thing left is a 9 and a z, a positive 9z. So plus 9z. So what that is actually called factoring. And you should have done factoring before in the past, so that shouldn't be necessarily new to you. But factoring is just where you can factor out the common factor. And since x is a common factor in both terms, you can factor that out. It's the opposite of the distributive property, because if I was to multiply both terms by x right now, I would get back to here. All right, so now that we have x outside here, x is being multiplied by this binomial, we call it. When there's 2 terms, it's called a binomial. And so we can divide both sides by that binomial to get the x by itself. So that's what I'm going to do. Divide both sides by this 3 plus 9z. It would cancel out those 2. They're exactly the same thing over itself. Leaves me now just with x. So again, I'm going to put x equals first. X equals this big fraction right here. The q over this 3 plus 9z. So I know some of these answers are going to be kind of odd-looking answers. You know, x equals q over 3 plus 9z. That is definitely a weird-looking answer, but it's just the way we get it with some of these literal equations. They come out to be some odd-looking answers, but you definitely want to make sure that when it says solve for x, you got x by itself equal over here. There are no x's anymore inside of this part, so that means x is only here. All right, for number 9, let's look for where x is. Again, it's in two places right there. It's with the 7, it's with the s. So the first thing I would need to do is get those two terms just by themselves on this side. I need to move this 4 out of here. So right now 4 is on the wrong side. I need to move 4 first to the other side, then I can deal with factoring out the x like I did on number 8 here. So the first thing to do is move the 4 over. So I'm going to subtract 4 so I can cancel those out, and I'm going to subtract 4 from the other side of the equal sign. So there's my equal sign. Make sure, again, you think of this as an equation. Equations are always like either a teeter-totter, where you have two sides to a teeter-totter, and you got to keep that teeter-totter balanced. Or you can think of it as a barbell. If you lift weights, then the equal sign is like the bar, and each side is the weights that go on each end of that barbell, and you got to keep it balanced. So again, if I'm going to take 4 off of this side, I got to take 4 off the other side of this equal sign. So again, equal sign's always got to be like the middle part where you see kind of do it equal to both sides. So when I do that now, I get r minus 4 over on the left side of the equal sign. And now these cancel, and I just have the 7x minus the sx. So again, I can't put them together, really. They're kind of like terms, sort of. So you could kind of do this, but it might be easier to think of factoring it out since s is not a number. If s was a number, then you could just combine like terms, and that'd be easier to think about. But here, I'm going to factor out the x again. So I got the r minus 4 over there still. X comes out. So out of the first term, the only thing left now is the 7. And then when I take the x out of the second term, it's only just that minus s. So now I get 7 minus s times an x. And I want to get x by itself, so I want to get rid of the 7 minus s. I want to divide both sides then by a 7 minus s. That means it cancels these two out here. And again, I'm starting with x is equal to. X is going to equal this big fraction here. That's what it equals. That's my answer. X is equal to r minus 4 over 7 minus s. Again, like I said, these answers are going to look kind of strange, but again, x equals, that's what it's got to say. Number 10. So if we identify where x is, we see x is in two places, and this time x is on different sides of my equal sign. They are like terms, 4x, 10x, but they're on opposite sides of the equal sign. So we definitely want to move them to the same side. So in order for me to keep this x term positive, I'm going to move them over here where there's more of them. There's more on this right side where 10. So I'm going to subtract 4x. Move the 4x to the other side. Subtract 4x from this side, it cancels it out. Subtract 4x from the other side. And so now I get y on this side by itself, y equals, and here 10 minus 4 is going to give me a 6x minus this 6 on the right side. Okay, so again, I'm trying to still continue to solve for this x. So now I need to get this term with the x by itself. I need to move the 6 to the other side. I got to add 6 to both sides. So that says minus 6, so now I got to say plus 6. I got to add 6. So again, opposite of subtraction is addition, to undo. So these two cancel. That makes 0 out of these two. And I get y plus 6 on that side, and it's equal to the 6x now on the right side. And the last thing now is to divide by 6, because this is multiplying. Opposite would be to divide. So when I divide by 6, x is now going to be by itself, and I want to say x equals first. X is going to equal this big fraction here. So x equals, you could say y plus 6 over 6, but what I did here to get this answer is I pretty much gave 6 to each one of these. So it's like a distributive property, but with division, with a fraction here. So y is over 6 in the first one. 6 is over 6 also, which 6 over 6 does equal 1. So you can kind of even simplify it to this, a y over 6 plus a 1. So that might be something we can do. I could have left it this way and still would have been okay, but I think maybe sometimes in the answers they may rather you do that. Number 11. So looking for x on this one, I only see it in one place. It's right there at the very end. And it's in the term negative 2x. So I need to get that negative 2x term by itself. I need to first move the 2r to the other side. Now there is another r here, so I'm going to combine like terms with that when I move it. So I'm going to subtract 2r to remove it from this side, and I got to do the same thing to the other side. Subtract 2r, but there's a like term to combine it with. So I'm going to have a 4g, and if I take 1r away from this, I'm going to have a minus r. So 4g minus r is going to be on my left side, and the right side now only has the term that I needed by itself, the negative 2x. So now I need to undo negative 2. And since it's multiplying x, I have to divide by negative 2. Again, by exactly the same sign here with division. So that way negative over negative will leave my x positive. So that means I'm going to say x equals first, and then this fraction is my answer right here. So actually, I didn't put x equals first on this one. I showed you could leave it this way. I left the x on this side. Okay, that's fine. And again, I didn't make this whole big fraction here the answer. Now, I could have just said this whole big fraction is the answer, but again, I simplified it down. I gave negative 2 to each term that's above here in the numerator. So 4g is over negative 2. So that would leave me with a negative 2g, because 4 divided by negative 2 is negative 2. So the first part can be negative 2g. And then negative over negative would be a positive, because this r is negative, and it's r over 2. And that's what x equals. And I just showed that you can leave it like that too. That's fine. You know, this equals x. I typically like, again, putting it in front. On number 12, let's look at for where x is. I only see it in one place again, right there. So the first thing we need to do, we have to see we have two terms surrounding this 3x term. I need to get that 3x term by itself. So I need to move both the 12 and this minus z to the other side. So you can start with either one, it doesn't matter. I'm going to start with the z. So I'm going to do the opposite of minus z, that would be to add z. So I'm going to add z to the other side, and there is a like term it's going to combine with. So I'm going to have a 3z and a 1z. I'll make 4z now over here. But at the same time, I'm also going to move the 12. So I'm going to subtract 12 as well. That cancels the 12 out. And I'm going to bring the 12 over here, and is there a like term to go with 12? Just that 8. So the 8 and the negative 12 can combine as well. So now on this left side, I'm going to see 4z from here. And if I take 8 away from 12, I'm going to see minus 4. So 4z minus 4 is now on the left side. On the right side, these 12s cancel, these z's cancel, so the only thing left is the term I needed by itself, which was the 3x. And now I need to divide both sides by 3. So to undo this 3, we divide by 3. Again, it's not the opposite sign, it's the same exact sign. So 3's cancel, and I see this could be my answer, or I could separate it like I've shown you before. I could say 4z over 3 minus 4/3. Okay, so x could equal either one of those. You could leave it as this big fraction, or you might need to separate it. Sometimes the answers want you to separate it. So on this time, I just left it as the one big fraction to show you can leave it that way. And I did put x in front, just like I like doing there. I could have left the x back there like I did on number 11, but I like keeping x equals here typically. And this time I did leave it in the big fraction, but I could have separated it like I did in these last two. I could have said 4z over 3, or 4/3 z, could have said that too, minus 4/3. All right, let's move on to our next part. But first, before we get to that next part, let's go ahead and look at our joke of the day. So here's the question: how do you make antifreeze? How do you make antifreeze? If you're not familiar with what antifreeze is, it's something you put in your car. But we're going to have a play on words. How do you make antifreeze? Well, you steal her pajamas. So if you steal your aunt's pajamas, she's going to get cold. Right, that makes sense. Okay. All right, moving on. Okay, so back to page 24 where that vocabulary is. So we're out of the literal equations. Those were that first part right there where we just saw just literal equations. Now we're going to move into formulas. Formulas are literal equations, but they're more specifically in tune with something we use to be able to solve for, in this case, like, you know, this surface area of this, you know, rectangular prism right here, this like box figure. And so things mean something. Our letters now mean something, you know, like L would stand for length, and W stands for width, and H stands for height, and the S stands for the surface area. So that's what formulas are. They are literal equations, but they actually have meaning. So that's what we can say there. A formula shows how one variable is related to one or more other variables. So you can write that, or you can kind of write what I said. It is a literal equation where the letters do have meaning. They represent specific things. So however you want to write down your definition, that's fine. It can be in your own words, whatever works best for you. So on this one, you can see what we're doing here. We're going to solve for a particular one, and it did highlight my L. So we want to solve for it. It says solve the formula for the length. So again, you got to first figure out what letter do they want you to solve for. They will either highlight it for you, or they'll tell you like it says here. And so as I'm doing that, we'll see that that's what they're going to do. They're going to start to get the terms with the L by themselves, so they got to get rid of this 2WH. That's what they're doing first. And then they got to somehow get rid of, or factor out the L. That's what they did there. Remember, we saw we did that before. They factored out the L. Now 2W, 2H, and then they want to divide by that right there. Divide by the 2W and the 2H on both sides. Now L is going to equal this big, kind of ugly looking fraction right there. That is what their answer is right there. That's what L equals. All right, so let's try some on our own in our extra practice. All right, so page 25 still has 13 and 14 on it. Actually, yeah, hold on. Okay, so yeah, I fixed that now to put 26 up here, because actually 15, 16 are on page 26. So page 25 still has the 13, 14 here, and we are solving formulas. It says solve the formula for the indicated variable. So again, got to identify what letter do they want us to solve for. So on number 13, it's an area, just the area of a triangle. And it should be a formula that you're familiar with. Yeah, these are formulas that we do use in math, especially when it's ever talking about area or volume or something like that. Definitely will use those. So we're solving for B here on this one. And so we're going to start by seeing that, there's our B inside here. So what I need to do is get rid of, first, this fraction. So fraction right here, I'm going to, instead right now, I'm going to divide, it's being divided by 2. Get rid of the denominator by multiplying both sides by a 2. So that's why I put the parentheses around the A to show multiplication, parentheses around this side of the equal sign as well. And I'm going to multiply both sides by 2. So when I multiply by 2, the 2's here can cancel, and that just leaves you now with a 1BH or just BH, and then 2 times the capital A is 2A. So it's going to be 2A is equal to BH. And now I need to see how I got to undo this H here. I got to get rid of H. So I have to divide by H. Right now B is being multiplied by H. So to undo the H, we have to divide by H. When I divide by H, then I'll have B by itself. So the answer is going to say B equals, and it's this fraction over here, 2A over H. That's my answer. B is equal to 2A over H. For number 14, the volume of a cone. Here's the volume of a cone formula. And you probably don't really need that until you get to geometry. But sometimes this can be helpful if you're ever going to work with any kind of cone situation and trying to find the volume. So the first thing we identify is we're solving for H, right there, for H. H is right over here at the end of this formula. And so we need to get that by itself, but since there's a fraction here, just like there was the 1/2, we want to undo that fraction first. So get rid of fractions always first out of anything, and when you're trying to solve an equation. To do that, again, we're just doing the same thing. This time we're going to multiply both sides here. Again, put parentheses around both sides, around the V, around this whole side here. Multiply by the denominator, 3. And so we're going to multiply each side here by the 3. So you can see 3 times V is going to be 3V over here on the left. 3 times this one here, the 3's cancel. And now you just have a 1 pi r squared h. So you don't even need to write the 1. You can just say pi r squared h. So that's what we're going to say there. It's just pi r squared h now on this side. Pi is that special number 3.14, but we don't need to really worry about it. Just keep it in its symbol form right now. Now to be able to undo all of this here, I got to get h by itself. All of this is still multiplying h. Pi is multiplying h, r squared is multiplying by h. So to undo these two, you just divide by these two. So we're going to divide both sides by the pi r squared. So if I divide by pi's, that cancels pi's out. It cancels r squareds out as well, leaves me just with h by itself. And again, I'm going to put h equals, and it equals this big kind of ugly fraction over here. 3v over pi r squared is my answer. So h equals that. All right, so now you want to turn the page over to look at page 26 for number 15 and 16. So here it says on 15, this is Ohm's law. This is more of an obscure kind of formula. You might not see that till much, much later. But we're trying to solve for r. So you can see r is this one. R is right here at the bottom. And so we're solving for r. R is in the denominator right now. And again, we don't want the fraction to be here. So the first thing I need to do is get rid of the fraction by multiplying both sides by r. So when I do that, I multiply both sides by an r. These r's cross cancel right there. And so that leaves me with r times I, or just ri on this side over here, or I put ir, it doesn't matter, you can say ri or ir, either one. And then over here we just have v, so it just equals v. But we're not supposed to solve for v. If we were supposed to solve for v, I'd be done. It says we need to solve for r, so now to solve for r, I got one more step to do. I just need to undo I, divide both sides by I. So when I divide there, the i's cancel. Now r will be by itself here, and r equals this fraction of v over I. And that's my answer, just r equals v over I. Number 16, here's an ideal gas law. Okay, so again, another obscure kind of formula. We don't use this one very often. But we do need to see, okay, what are we solving for here? It says solve for r. And so you can see r is right in the middle between n and t on this side. So the first thing I need to do is undo the n and the t. They're both multiplying r, even though they're on both sides. This is all multiplying n times r times t. So to just get rid of the n and the t, divide by just n and t that you're trying to undo. So you can cross cancel n, these cross out, and t's will cross out, leaving you just with r by itself. But again, we have to do the same thing to the other side. Divide the PV here by the n and t as well. So my answer now is going to be just r. I could say r is equal to this big kind of fraction here, PV over the nt. And that's it. R is equal to that fraction, and I'm done. All right, so we just have like one more, and then we'll be out of here. All right, so back on page 24, there is this core concept that shows you some common formulas. There's one for temperature, one for simple interest, and one for distance. So for temperature, this is actually a very helpful formula if you ever travel anywhere, if you go outside of the United States, I should say. If you ever travel outside of the United States and you're watching the news and you're trying to figure out what's the temperature going to be for tomorrow, they're going to say the temperature in Celsius. We usually say the temperature in Fahrenheit. So if we're going to say, well, it's going to be, 90 degrees tomorrow, we're talking about 90 degrees Fahrenheit. That's not the same thing as Celsius. So if they say, okay, it's going to be 5 degrees tomorrow, you might be thinking, wow, that sounds really cold. But it isn't as cold as you might think, because it's going to be in terms of Celsius. So that would be helpful when you actually travel. Simple interest, this is something that you can use to, figure out maybe some banking issues. So this would be more of a banking kind of formula. The distance here is, again, traveling things. It's a distance traveled. The rate would be your speed. The rate in this one is a little different. This is a percent rate of interest. And then t here is still time, and time here, but time in this interest one is usually always in years. The time here might be more in hours or minutes, seconds, those kind of things. So time in the distance formula could be different. And here's the formulas. You have your what C equals 5/9 times this Fahrenheit minus 32. Interest, I equals PRT. The interest equals the principal times rate times time. Principal is always your starting amount. And then distance equals rate times time, R times T. All right, so let's just look at a few problems here. You can see that here's one for formula. It says solve for F. So if we wanted to solve this for F and say, okay, let's say that they tell us what the Celsius is, but we want to figure out what Fahrenheit is and so on. We could solve for F. We want to get rid of our fraction. They multiply both sides by the reciprocal of 5/9. That's 9/5 now times the C. they're going to add the 32 to both sides, which they did, and there it's done. F is equal to this. So if they tell you in some other country you go to that it is going to be 5 degrees Celsius tomorrow, then you put 5 in here for C, and it's going to be, cross cancel the 5s, and now it's just 9 plus 32, so that's actually going to be 41 degrees. That's just still pretty cold, but it's not as cold as 5 degrees would be in Fahrenheit. Here's another one talking about planets. They got Mercury and Venus close to the sun. It says which one has a greater surface temperature, Mercury or Venus? So it's going to say, okay, here it tells you the temperatures. It's 427 degrees Celsius on Mercury. It's 864 degrees Fahrenheit on Venus. Again, using that formula there. So we would want to, you can figure out if you plug in a number for C. So this is when they're going to plug in the Celsius number they know for Mercury into here, and then they're going to multiply this, times this 9/5, and then add 32. It gives them 800.6. That's what Fahrenheit is. So Mercury was actually 800.6 Fahrenheit. So that means Venus is actually got the greater surface temperature. They're still both really hot. Obviously, we wouldn't be able to live on those planets ever. You could never even go to those planets because you would just, melt. Here's another one with interest. We're actually going to do an interest problem, so I won't talk about this one. I'll look at the one we're actually going to do on 17. Here's one about a distance formula. So it's talking about truck drivers driving 60 miles, and, it's a return trip. Average is 50 miles per hour, and so on. So you're using a distance formula. So there's the distance D equals RT, and you want to solve it for T because they're looking for time. They say how long does each trip take, so that's time. So you want to be solving this for T. That's what they're doing, and they're solving for T. So I won't do that much more than that. That's fine. You can look at that in the book if you have your book. Oops, not yet. So let's go ahead. All right, so here's number 17 on page 26. Our last one says the amount A, and this is an interest problem. The amount A of money in an account after simple interest has been earned is given by the formula A equals P plus PRT. So the principal plus the principal rate times time, where P is the principal, R is the annual interest rate in decimal form, and T is the time in years. So first thing, letter A says solve for R. So we're going to just go ahead and write down that formula we're going to use, and we're solving for R. R is between right here P and T. So go ahead and pause the video, solve for R, see if you can get that solved for R properly. All right, so hopefully you got an answer here for what R equals. The first thing we need to do is move this P to the other side. We want to get this term where the R is in by itself. So I'm going to first subtract P from both sides. That leaves me with an A minus P here on my left side, and it's equal to the PRT on the right because those P's are canceling. And now I need to undo the P and the T because I'm solving for R. So undo P and T, divide both by P and T. So the P's cancel and the T's cancel. Leaves me with R by itself now, and R equals this big fraction right here. It's kind of the ugly fraction of A minus P over PT. Now, letter B says the amount of money in an account after interest has been earned is $1,080. Okay, so that is the A. Okay, that's the amount of money that's in the account. That's your final amount. That's our A number from our formula up here, A, or A is now here in this one. The principal is 1,000, so it's obviously P for principal, and the time is 2 years. So that's the T in the equation for time. We're going to use 2. We're trying to find what the rate is. So what is my rate? So that's why we solved for R, so that we can just plug in the numbers in here and then calculate that and figure out what does R equal. So when I plug everything in, we're going to see that it's going to be the 1080 minus 1,000 on top. So R is going to equal 1080 minus 1,000 from A minus P, and then it's going to be the 1,000 times 2 on the bottom from the principal times the time. So 1,000 times 2 at the bottom. So if I do 1080 minus 1,000, that's 80 on top. and this is going to be 2,000 on the bottom, so it's going to equal 80 over 2,000. And what we can do there is now use our calculator to divide and get a decimal. So we can say that we have 80 divided by 2,000, and that's going to equal 0.04. So my number there is 0.04. That's in decimal form, but if they said, okay, what's the annual interest rate, we're going to probably want to make that into a percent. We would need to move the decimal back 2 places to make a percent out of that. So 0.04 is the same thing as 4%. So that's a 4% annual interest rate. And the last one here says on C, solve the formula for P. So if I come back up here to my original one here, and I wanted to solve for P, A equals P plus PRT, I'll go ahead and have you solve that for P. Just like you solved for R here, now you're going to solve this blue one here for P. So go ahead and pause the video, do that, and then check your answer. All right, so hopefully you have it solved for P. So what I would first do here, A is going to equal, I'm going to first, since P's in both of these, I'm going to pull out P. So A equals P, factor out the P. Now this is where it may be a little difficult. You may have made a mistake here. You might have thought, well, I'm taking P out and nothing's left. So you don't have to put anything there for that first part, but you do. There's actually always a 1 in front of a variable. Anytime you have a letter, there's always at least a 1 in front there. So there's never nothing left. So if I pull out P, I still have a 1 still to write, 1 plus. And if I pull out P here, it's just going to be RT left in the second part. So in the first part, there's still 1. In the second part, there's RT. So now to get P by itself, I need to divide both sides by this kind of binomial, 1 plus RT. So divide both sides by 1 plus RT. Those will cancel each other, leaving us now with P equal to this big fraction over here. That's what your answer should be. P equals A over 1 plus RT. And so there you go. All right, so that concludes our lesson on 1.5, and you'll be ready on the next one to start chapter 2. And I'll see you there.